Hello guys, thanks for clicking this video. Today I'm talking about super smart short finder in layer of mainboard or in layer of any PCB board. Any short between the wire layer or working with metallized PCBs, short or loop inside or outside. Very good. First, let's talk about project. Here is the OPAMP short finder. I have a special video about this one. It is connected to the 3-volt regulator and 3-volt regulator connected to the 12-volt battery. The output of short circuit finder connected to the 168 at mega. It will work as soundable part because of we need to listen to sound of resistance. In short while we will check the resistance easily with the sound. In first 4 or 5 tests it is a little bit hard, but after that it's gonna be easy. Very good. The input of Arduino connected to the 2 leads. As you can see, one of leads have one push button here to calibrate, and the other lead connected to the alligator clip because of sometimes we want to work with the hand, and the hands-free need to connect the first side of the test project with this alligator clip. To start the project and check the project, I have a pipe over here and one damaged short loop wire is this side and the other side is the good quality wire. We are going to test this pipe wires, and after that we will try to check layer of the PCB metallized mainboard and check with the short amount resistors to know exactly how this project works. Of course, when any short connection happen between layer of the mainboard, it is very hard to find exactly what's going on and how we can fix this problem. But this device will help too much to find exactly shorts between the layer of PCB and other projects that we have problem about short connection or loop connection. First test, we will turn off the device. We will turn on device. We have a welcome sound here. It is on. The voltage over meter is 2.385. It is not necessary to use the meter because of we work with the audio sound, but for the first day test it is much better to check the amounts with the meter also. Very good. I'm connecting the first side of the testing solution to the alligator clip like that, and I'm going to other side to test with the other lathe. Very good. As you can see, I'm connecting the lead to the first part of the wire. It is silent. I'm pressing the key. You can see we have sound. It means that it is not good connection. We are going to next step. You can see we have more sound. And here is the voltage. It means that this wire is not good wire, and we have disconnection or short between layer of the local wire. And to test the device, we are going for the other side with the normal wire. Here is connected to the good wire also. I'm connecting the lead, then pressing the key. You can see it is completely silent. It means that the wire working properly well. I'm going to next step of the wire. The first time that we attach the lead, we have a sound, and when we release also we will feel a sound like that. But the thing that we should know is the sound during the test. For example, I'm connecting the lead, then I'm pressing the key several times. It is exactly silent. This is a simulation for the mainboard layer. We will go step by step and test this to find the area that may we have a loop connection inside the layers. For example, I'm going to test with this mainboard. Very well. To test the mainboard, the first lead alligator clip is connected to the ground, and I'm going to test one by one the points that it may have the loop connection. For the test, I add some solder over here to know exactly what's going on. As soon as I'm connecting the layer to the ground connections over here, we have sound. It means that we have loop connection, and the loop connection is near this point because of the blinking is fast, and we have non-stop sound with this device. I'm going the other point closer to that loop over here. I'm pressing the key. You can see we have too much sound and the non-stop and much faster. It means we are too close to this loop connection. And finally, when we arrive to the place that it is looped, the device gonna be silent like that. Now we have completely silent point, and it means we are exactly on the disconnection or loop place, and here is the point that need to fix or rework or solder the components. Thanks for watching. I will work more for this project to make it much smarter. For the IC I used AD811 for analog device. This IC work from 600 nanoamps as current measurement, and the slew rate is very nice, and also the IC is zero drift or no drift for the temperature protection. Thanks for watching and goodbye.